So today we'll be learning about our own chain, Comdex, and its multiple modules. So starting from the Comdex repository, we have the X directory here. And when you go in the X directory, you can see a list of modules. So each module has its different specific work. So right now we have one asset auction, band oracle, collector, ESM, lend, liquidation, liquidity, locker, market, rewards, token mint, and vault. So we'll be going one by one to each of the module and see how it's being set, how the data and all the other parameters, governance are being set, and what is the specific function of this particular module and how it's modular in a way that other module can access data from this particular module. So the first module will start is asset. So simply for creating an asset, we need to define its proto, or what we call it as structure, the structure of an asset. What should an asset have? An asset should have its name, its denom, IBC denom, what we should say, IBC denom, its denom and its decimal, how many decimal precision it has. For example, in Ethereum, we have 18-digit decimal precision, and in Cosmos, we have only 6-digit decimal precision. So we should define everything. So for that particular thing, we need to go into the proto directory. And in proto, when we go in the Comdex, we need to define all this structure for different modules. And it's defined in particular for asset, it's defined in asset directory. And when we go in asset.proto, what we create, we can see we have a list of things that are here. So here is an asset. So we write it in protobuf, and it's pretty simple. You can see we define an ID for an asset that is in form of uint64, the name, the denom, the decimal, is on chain, is the asset on chain, is Oracle price required. It's something like we fetch prices of all the assets that are registered on Comdex. So we define a flag, a Boolean flag, which tells if the price is required or not. And at the last, is CDP mintable or not? Can it be minted or not? If we are creating a vault, and again, vault is a very lengthy topic, but we'll cover it. So for right now, we can understand it. If we are depositing any IBC asset on Comdex and creating a vault, we are minting out something. So if we are enabling particular asset for minting or not, that defines this particular flag. So if we have to see any asset, how can we see like what all assets are present in Comdex? So we can simply go into the Swagger and we can access it. So here we have asset. Okay, we'll just try it out. And it's for assets. We'll just go for asset with particular ID. We'll try it out. And I go for asset ID 1 and execute. So here we can see we have asset, its ID is 1, its name is Atom, its denom is this IBC slash, and its decimal is 10 to the power 6, and is on chain. No, we are calling it from different chain, the Cosmos Hub. Is Oracle price required? Yes. And is CDP mintable? It's false. So pretty simple. And when we go to CMST, what we are minting on chain, you will actually see that is CDP mintable true, and is on chain true, means this particular asset is native on our Comdex chain. So this symbolizes that is on chain is true for this particular asset. So this was asset. Now we know how to like create structure for our particular module, and it's what we can say asset. So a particular asset will have a structure like this. You can also add any other, like any other required fields which you want by simply clicking or adding anything, whatever you may wish to create for this particular hackathon, and build it and start using it. So where we were on the asset module, right? So when we go on asset module, so now we have our asset asset particular structure created. Now we need to save it on our chain. So how we will save it? So right now we have something called as governance, which we have discussed on the previous class, like how validators uh, how validators are voting on a particular proposal, and how the governance is set, and if the quorum is reached, the proposal is passed and the asset is saved, or the state change take place and asset is registered on our chain. So we'll see how it is done. We When we go in client, all our CLI transactions are added, where CLI transactions, we go to transactions query. Whenever we want to query something, we can query and we can define it on chain, like which parameters need to be queried are defined here. We have query for everything, like for example, let me show you. It's defined in cli.1. Okay, so we can query params, we can query particular asset, we can query all asset, we can query pairs. Everything needs to define in this particular file. And similarly for transactions, when we go into transactions, everything is defined here. Like, just let me go again, add commands, add command. So right now there are no transactions, everything is under governance. So if we go to this proposal handler, we can see, yes, everything is defined here. For transaction, we have transaction.go, tx.go. For query, we can see all the query in query.go. You don't have to worry much about it, because in later sessions, we will be explaining how to create transactions, how to create queries on chain. Everything will be explained. But right now, I'm just letting you be familiar with how everything is handled and where it is located. So the proposal handlers are located in this particular proposal handlers file. And here you can see submit assets proposal, update asset, add pairs, update pairs, add app, add asset in proposal. Everything is defined here. Whatever proposal we want to execute, or we want to have any state change that for which we require an proposal or a voting, everything is defined here in this particular file. Similarly, for transaction, we don't see any particular transaction. Yes, in transaction file, we create the transaction for that particular proposal, right? So for that particular proposal, we have new CMD submit, add multiple assets proposal. So how to use it? We'll simply provide, like in previous class we saw, we simply write the Comdex and then transactions. Just let me show you. Comdex TX. So we have a list of things. Now what I have to do, I have to do a Comdex TX gov, because it all comes under governance, and all the governance subcommands can be found under this thing, gov. So what I'll do, Comdex TX gov. So here you can see a list of commands: shine, sign batch, multiple sign, and we have to search for proposal, deposit, vote, weighted vote, and submit proposal. What we have to do, we have to do a submit proposal. So here is a list of proposal that is present on Comdex chain. Add lend pairs for, but right now we are looking for assets, add assets. So if we see add assets, so see here, Comdex TX gov submit proposal add asset, and we need to define flags. In flag, what we have to do, add assets file and attached a JSON file. I have a JSON file created in my local system. Let me show you. Asset, asset CMST. So see, I create a JSON file similar to this, what I want. The name I want CMST, denoms UCMST, decimal 10 to the power 6 is on chain, 0 for true, 0 for true, and 1 for false. So as asset oracle price required, no, I don't want, because it is native to my chain and I will be getting it through my pools. So everything is defined here. and we define a title, a description, and a deposit. So for creating any governance proposal, we need to deposit some tokens so that it can, so that what we can say, uh, whenever there are spam proposal, it can be reduced. So we need to have something to deposit on it, and later on, when the proposal is in voting period, people come or validator come and cast their vote if they want this proposal to go live on our chain or not. So this was a summary of it. So here we are in transaction, and when we go in expected, we have something called keeper.go. In expected, what we do in expected the directory, we keep a list of all the functions that we require in this particular module. So this particular asset module is calling functions from bank module, rewards module, vault module, and band oracle module. So asset is the basic, like what we can say, basic building block for any application that you are building on Comdex. So you need to define your own asset, whatever you are creating for your project or anything, or whatever you are taking, like taking out or getting from any IBC chains or anything. You need to define your own asset if you want to create something and run something on Comdex. So you need to first, you need to define an asset, then something is there, then another thing what you can use is an app. So we have something called app is something like but an individual product. For example, if you want to create, right now we are having three apps. First one is C Shop, second one is Harbor, and third one is Komodo. So why we define app? So for example, every transaction is taking place in our Comdex chain, and how you will be able to classify it? Yes, like this one is particular, or this particular token what we got in fees is from Harbor, or this one is from Komodo, or this one is from CSWAP. So we have a collector module where we keep a track of all the fees that is being collected, whether it be drawdown fee, liquidation fee, or anything. We keep a track of all the fee with their respected apps. So app can be easy to classify any transactions or any calculation that is being taken place by particular set of codes for that particular product. So this was app. I'll show you the structure of app. It's pretty simple. Yes, it contains the ID, it contains a name, short name, minimum governance time, minimum governance deposit, and minimum governance time in second. And we have also something called as Genesis token. In Genesis token, we have asset ID. Like for example, Harbor has its own Genesis token as CMST. So we need to first create the asset CMST and then define it as a Genesis token, and we need to mint it for sorry, not CMST. Harbor has its own governance token as Harbor. Sorry, my mistake. Harbor. So we need to specify a Genesis supply, and is it a governance token or not? So yes, it's a governance token, and on which address, after minting, on which address the Harbor should go, that's defined in this particular structure. And similarly, app ID, governance ID in second, everything is defined here. So this was basic. And if you don't need to have any separate governance for your app, you just leave it empty and create your own app. For example, we can see app will go with ID2. ID2 is Harbor that has its own governance token named as Harbor. So see here for asset ID 9, we have a Genesis supply of 5, 1, 2, 3, something, and is governance token true? And this is the recipient of that particular Harbor that is being minted, right? And also we defined something as governance time. But if we go for Pomodo, that is asset ID 3, and we execute it, we see we don't need any minimum governance deposit because our CMDX will be the base governance asset, and no governance timing second and no Genesis token. We don't need it. So that was it. So the basic thing that like why I explained app and asset in such a detail, because whatever you will be creating, it will require an app and an asset. So this was important. So right now we can move into the next modules. The another one which I'll be explaining is auction. So in auction, we have two kinds of auction. Explaining auction in like in short, what we can say, auction is something when you create a position or when you mint something. For example, you have atom and you went to the vault module and created. Let me show you. Comdex TX vault. You went to the vault and created a position, a CDP. Now you have put in 10 atoms. Suppose the price of atom is $10. So you have put in $100 worth of atom, and now you want to mint $80 worth of CMST. So now, for example, everything is over collateralized, and the maximum what you can take out from this particular CDP or particular vault is 80%, right? So if in any case the price of CMHT is not going up because it's a stable coin, so only one case that is probable for liquidation is the price of atom falling below its particular, what we can say, LTV, loan to value ratio. So in that case, for example, the value of atom goes to $9. So right now, the value of your collateral is $90, and what you have taken out is $80. So there is a further risk of price getting lowered of atoms. So in that case, what we do, we have a safe side, what we call as like liquidation threshold. Like below this point, if any asset prices go below this particular point or particular ratio, then we will liquidate it and recover the CMST. So how CMST was like how he minted, but that 80 CMST. So now his position of atom 10 atoms will go to liquidation and then auction, and that 10 atom will be auctioned. So right now we are having Dutch auctions in which the price starts from a particular ratio. Like for example, if the price of atom is $10, so it will start from $12 and it will linearly decrease till it reaches around $8 to $9. Everything is defined. So we have a step like how many decimals or how many points we are decreasing per block. So this everything is defined in the code. I'll be explaining you. So this is how we, and the background process, what happens when you have created your position, you have sent your atoms. Let me show you. When you create your mint position, test, sorry, it's test cases. Okay, so when you create your position, you send atom from your address to my vault module. So see, here we can see, here we are utilizing the bank module k.bank.send coins from account to module. So we are sending coins from the user's account who is creating the vault to our module, right? So we are passing in the context and depositor address from which the coin has to be deducted and sent to the user's module, our vault module. So depositor address, then types.module name, to which module we want to transfer it, and how much coins we are transferring it. Everything is defined. So we are taking an asset in data dot denom, the denom of the token, and message dot amount in whatever he is putting in. So this is how the coin is transferred from the user's address to the vault module. And in case of liquidation, the same amount goes from our module name. So in that case, we won't be using send coins from account to module. We will be using the case send coins from module to module, right? So what it does, it sends the tokens from vault module to the auction module. And when the auction is completed, the bidder who is bidding gets the atom, and that process takes place from the function send tokens from module to account. So bank module that is of Cosmos SDK has this particular functions, and for using this particular functions we need to define it in expected, what I have said you earlier. In expected you can see all the functions. We have burn coin, we have mint coins, we have send coins from account to module, send coins from module to account, send coins from module to module. And here we can see spendable coins, like how many coins a user's address is having. It's basically for check that yes, the user is having this much tokens before creating his position. So this was for auction module, how it works. Similarly, in Vault, you can create a CDP, open a position, lock in your atom, mint some CMST. And if you are wishing to create something on top of Vault, you can create your own app and have your own utility. You can define your own module, which we'll be discussing in next sessions, like how to create your own module and create a usability or functions on top of Vault. You can utilize the Vault code, Vault structure, and create something on top of it to create or mint anything you want, mint an NFT or anything, whatever you want, right? So this was Vault. Now coming to Band Oracle. Band Oracle is a very important module for working of Harbor protocol and Komodo protocol. Why? Because we are fetching prices from Band Oracle. So for fetching prices, we define channels, and through that channels, we are sending in packet. We are sending in the asset name, like, yes, I want prices for Atom, prices for CMDX, CMST, everything. And in return, the band module sends us back the prices of all the assets which we have requested. We can see here Cosmos scan. Here we have a particular Oracle scripts, we define Oracle scripts, and through that Oracle scripts, we fetch the prices through data scripts, and through multiple validators validating the price of a particular asset, the prices are then sent back to the Comdex chain. Let me see if we are on testnet, we can simply go on to mainnet, or let us be on testnet only. So see, here is something, request ID. So here we are requesting prices for Atom, CMDX, CMST, Osmo, Harbor, WETH, Canto, Gold, USDC. And here is the response what we are getting. Price of Atom is 9.19, 0.03, CMST is 0.99. Everything is defined here. And we are getting the result. And here is the rates of that particular asset in the same order, like on the same order in which we are sending the request, the same order we are receiving the prices. So that is done through this particular Band Oracle module. We need to define a channel. We need to create a channel, and we need to pass a proposal to like fetch price from this particular Oracle script ID. Now, told you about the collector module. Collector module collects the fees from all the apps that are being used on our Comdex chain, and it keeps a track of everything, like all the fees that is being generated. So it's a ledger for our own Comdex chain, we can say. Now moving to ESM. ESM is emergency shutdown module. So it's a custom module that is built for the apps in case of any emergency or any hack or anything. It is designed in a way so that we can restrict individual function or individual apps. For example, if there is something like if the prices are fluctuating very much and we need to restrict some actions for a particular app, we can enable in ESM for that particular app, or even for particular function, we can enable ESM for that particular functions also. So that was the function of ESM. Again, if we go to lend controls the borrowing and lending part of the Comdex chain. Through lend, you can create your own lend positions, and you can borrow from the same pool. And if your liquidation threshold is reached, again, the liquidation and auction modules are being called. So now going to the liquidation module is very important because it utilizes the begin and end blocker. So the problem with Ethereum was like it doesn't allows a state to be iterated over and over by the chain. And in Cosmos, it allows iteration over state through particular functions that are known as begin blocker and end blocker. I am showing you in ABCI. We have begin blocker. So in every begin blocker, what we are doing, we are checking this particular function liquidated vaults. It iterates over all the vaults and see if the vault is faulty, or if a borrow position is faulty or not. It will liquidate them and send them to auction. So the main work of liquidation is to iterate over the states of all the vaults and borrow. So in liquidation, what we can say, liquidation is the most like memory intensive module that is built on Comdex. Now moving to liquidity is simply AMM that is being used for swapping or creating pools and pairs that you want to like create a pool for a particular assets or a particular pair you can create using this particular liquidity module. Now moving to market. In market, what we do, whenever we fetch the prices of all the modules, all the assets, we create a TWAP. What is a TWAP? TWAP is time weighted average prices of that particular asset. For example, we fetch prices of Atom up to 30 blocks, 30 prices, 30 blocks or 30 prices, whatever we say. And we create an average for that 30 prices, whether it be 9.19, 9.2, 9.3, again 9.1. We store the prices up for the last 30 blocks, and we create an average out of it. And again, for creating a vault position, we use the TWAP prices, not the actual prices that is coming right now, because it may trigger liquidation if someone is creating a vault and again at the same moment it is liquidated. It's not good. So we use TWAP. It is also useful if someone tries to fluctuate, or some asset is falling or increasing, or there's a huge price movement in any of the assets. Now rewards is something like, for example, you have created a pool and you want to attract users on that particular pool. For example, if you are creating a pool, if you are creating a NFT pool and you want to incentivize anyone who is swapping, or anything that you want to incentivize for any action, you can create it. You can create a reward for that particular thing using the rewards module. For example, in CSwap, you are providing liquidity and you are a farmer there and you have logged your tokens, so you are eligible for rewards. Also, if for a hackathon, if you are creating a particular pool, for example, if you are deploying a game or anything on Comdex, and you want to incentivize a particular action, like someone is minting, then he should be rewarded in my tokens. You can all create that thing using that reward module. Similarly, token mint is for minting particular token. So you don't have to worry about, yes, I'm creating my own project. How can I mint my own token? So you can simply create XYZ token for your particular app, and that is being done through the token mint module. And vault module, which I've already explained, is for CDP. So that was all for the Comdex module. Now, what I will suggest you guys to do is simply get the binaries of Comdex and try running it. Comdex TX, and go and see each of the modules and rectify, like, how many transactions are there, what are the parameters they are asking for, and what are the queries present, how can you leverage them, or whether you can replicate it and create it your own module. So try looking into it and see what else you can do. So this was it for the Comdex module overview. In upcoming sessions, we will be learning how to create a module and all the transaction functions and everything from scratch on Comdex. So we can end this session.